For decades, the story of American manufacturing was pretty much all about decline. But that story is changing, and it's changing fast. Today, we're going to dive into one of the biggest economic shifts happening right now, the surprising, tech-fueled comeback of manufacturing, right here in the US. I love this quote because it just nails the shift in thinking, right? For the longest time, all the exciting, cutting-edge stuff was happening in the digital world, in code, in apps, and things you couldn't actually touch. But that's changing. Building real, tangible, physical things isn't just cool again, it's being seen as absolutely essential. And that brings us to the big question. Why this massive push to bring manufacturing back home, and why is it happening right now? This isn't just about patriotism, it's about a bunch of powerful global forces all converging at once. So what's really driving this tectonic shift? Well, it pretty much boils down to three huge forces. First, you've got geopolitics, which is making companies completely rethink where they build things. Then, of course, the pandemic was a massive wake-up call, showing us just how incredibly fragile our global supply chains are. And layered on top of all of that is this growing realization that, for our own security and stability, we just need to be able to build more stuff at home. But here's the thing, rebuilding an entire industrial base, well, it's not like flipping a switch. After decades of moving production overseas, American companies are waking up to a pretty sobering reality and a set of 5 massive interconnected hurdles they have to overcome. The first challenge is a big one. It's basically the ghost of everything we've lost over the years. The entire support system has just withered away. Think about it. A factory can't exist in a vacuum, right? It needs this whole network of specialized suppliers, tool makers, and process experts. And after so many years of offshoring, that network in the US has pretty much disappeared. Just ask TSMC, the world's top chip maker. They found out in Arizona, you can't just build a brand new factory, you have to rebuild the entire industrial community around it, basically from scratch. And that problem with the ecosystem, it leads directly into the second hurdle, which is a very human one. The know-how is gone. We simply don't have enough people with the specialized skills needed to run these incredibly complex modern factories. It's not just about a lack of jobs. It's about the deep institutional knowledge for large-scale manufacturing that has just faded away over generations. Now, get this. This quote from Siemens just shows you how huge the problem is. They were building a new facility in Texas and couldn't find the skilled labor they needed. So what do? Something totally radical. They started hiring school teachers and people from Starbucks and McDonald's, and then they trained them from the ground up. It's incredibly creative, but it also shows you what a massive challenge building a modern workforce really is. Okay, so from the challenge of building new things, we move to the problem of what's already here. Hurdle number 3 is dealing with America's existing brownfield factories. These are the older plants, the ones packed with old machines that aren't connected to the cloud. And here's the real kicker, something a company like Caterpillar knows all too well. Demand is through the roof, so you can't just shut these places down for a year to give them a digital makeover. You literally have to perform open-heart surgery, upgrading them on the fly while they're still running at full speed. And that intense pressure to keep the old factories running leads us right into the 4th hurdle, which is the brutal reality of the clock. It's not enough to just build a new factory. You have to get it running at full capacity, and you have to do it fast. Take a pharmaceutical giant like Eli Lilly. They're investing billions to produce new drugs. For them, every single day of delay in getting a new factory scaled up has huge real-world consequences. The pressure is immense. And finally, we get to the 5th hurdle. This is the one that literally powers this entire rebuild. Modern factories, especially ones making things like semiconductors, are incredibly power-hungry. They put a massive strain on a national power grid that's already stretched to its limits. It's a really simple and stark equation. The amount of available energy is the absolute ceiling for growth, period. Without more power, this whole industrial rebirth just hits a wall. Okay, so the challenges are huge, no doubt about it. But this rebuild is actually happening. And it's because we have a new digital toolkit that is a total game changer. Let's look at the key technologies that are making all this possible.
First up, we have the digital twin. The easiest way to think about it is like a super realistic, physics-accurate video game version of your factory. It's a living, breathing model that's constantly being fed real-world data. So in this virtual world, you can test out new layouts, train your workers on new equipment, and optimize your production lines down to the millimeter, all before you ever tighten a single bolt in the real world. It's incredible.
And then there's physical AI. Okay, so think of an old-school factory robot that just welds the same spot on a car door over and over again. That's not physical AI. Physical AI is what lets a robot see a screw that's been dropped on the floor, recognize what it is, figure out how to pick it up, and put it where it belongs. It gives robots the brains to perceive, understand, and adapt to the messy, unpredictable reality of a factory floor. That means they can finally work safely alongside people and handle all kinds of tasks that aren't perfectly repetitive. All right, so theory is one thing. Let's look at how these game-changing tools are actually being used by industry leaders to tackle those 5 big hurdles we were just talking about. This is where it all comes together. Take TSMC. They're battling insane complexity by building a virtual fab first, so they can iron out every single kink in the digital world. Then you've got Caterpillar. To upgrade their old brownfield sites without shutting them down, they're using intelligent robots as roving sensors to map out all the old machinery. Eli Lilly is using digital twins to test and perfect their manufacturing processes so they can scale up way faster. And to tackle that labor shortage, companies like Agility Robotics are pioneering what they call a digital human workforce with actual humanoid robots. And what's happening between companies like TSMC and NVIDIA, it's just a perfect example of a virtuous cycle. It's actually amazing when you stop and think about it. Step 1. TSMC makes the super advanced chips that power NVIDIA's AI computers. Step 2. NVIDIA uses those chips to build the most powerful AI systems on the planet. Step 3. TSMC then buys those exact computers and NVIDIA software and uses them for what? To design their next, even more advanced factory. Each innovation is literally building the tools for the next leap forward. So what's the takeaway here for any company that's trying to navigate this new industrial age? Well, the experts who are on the front lines of this stuff have a pretty clear playbook. So what's the playbook? It's pretty straightforward. First things first, always start with your business goals, not the flashy new tech. Second, you have to embrace controlled experimentation. Be willing to try new things to find better ways of working. Third, think about the whole picture. I mean, sometimes the first step to deploying a humanoid robot is just upgrading your factory's Wi-Fi. Fourth, don't try to boil the ocean. Pick a problem and solve it in a manageable, bite-sized chunk. And last but not least, for goodness sake, call your utility company early. Look, this technological revolution is already here. It's letting us build things we never thought possible, right here in the US. But it leaves us with one final and absolutely critical question. We are building the factories of the future today, but are we really preparing the workforce of tomorrow to run them? And are we building a society that's truly ready for this next industrial age?